अनिमेश जी करें क्या? स्टार्ट करेंगे? करें ना? In the words of Thomas Edison, the first requisite for success is the ability to apply your physical and mental energies to one problem incessantly without growing weary. A very good morning to our distinguished guests. I am Sophia Jamil, and along with my co-host Sarmishta Das, it is an honor to commence the journey of the global initiative of Academic Network's International Winter Course 2024. I am delighted to request all the distinguished guests, Associate Dean of Research and Development, Dr. Anup Keshri Sir, Gyan Professor in Charge, Professor Amit Kumar Singh, our esteemed speaker, Professor Adam Jadwat Sir, Dr. Shiparna Saha, to kindly take their seat on the dais.
Firstly, I express my gratitude to our esteemed Associate Dean of Research and Development, Dr. Anup Keshri Sir. Additionally, I would like to acknowledge the Gyan Professor in Charge, Dr. Amit Kumar Singh Sir, whose unwavering support has been a continuous source of motivation for the commencement of this program. Subsequently, I wish to extend a special welcome to our esteemed speaker, Professor Adam Jadwat Sir, and acknowledge our Professor Dr. Shiparna Saha for hosting this beautiful ceremony. And last but not least, a heartfelt welcome to the bright and enthusiastic students gathered here today, who are the heart of our academic community.
Before we proceed further, let us add a luminous touch to this inauguration. In the tradition of knowledge and enlightenment, we will now light the ceremonial lamp. May I request honorable dignitaries to begin an auspicious event by lighting the lamp. On the other hand, I request Saurabh Sir to play the Saraswati Vandana and solidify the ethnicity of this Gyan winter course.
So this is just a tradition. You have to. Yes, Shri Vandana. Chalu kar di Anniversary. Anniversary.
Thank you, everyone, and may your insights and wisdom continue to guide our path as we embark on this journey of knowledge and exploration.
Sir, please have a second.
Okay, so all of you, please, may I have your attention? So we would like to also invite Dr. Arijit Roy sir to present in this moment. And also I would like to thank Shiparna ma'am and also the students to encourage. And I would like to request Shiparna ma'am to share a token of appreciation to the professors. So I would like to request Dr. Shiparna to extend her acknowledgement by presenting a token of appreciation to the Associate Dean R&D, Dr. Anup Keshri sir. Okay, so first I would like to request Dr. Shiparna to share this token of gesture to Professor Adam Jadwal sir.
Special painting for
Mathubani painting sir.
Yeah.
I would like
This is a small pot. Nowadays we have replaced the bouquet with a
Oh, okay, okay.
more greenery, greeny eye.
Thank you.
Now I would like Dr. Shiparna ma'am to give a token of gesture to Dr. Anup Keshri sir. Now please ma'am give a token of gesture to Dr. Amit Kumar Singh sir.
Thank you. तो बोले क्या है?
Now I would request Dr. Shiparna Shah to give a token of gesture to Dr. Arijit Roy sir. Now I would request Dr. Anup Keshri sir to present the token of gesture to Dr. Shiparna ma'am.
Without further ado, I invite Dr. Shiparna Saha, the esteemed Associate Professor of the Department of Computer Science and Engineering, to commence with the inauguration, setting the tone for what promises to be an enlightening and inspiring event.
So good morning to all. So all the dignitaries on the dais, Professor Adam from the University of Innsbruck, Austria, our long-time collaborator. This is the first time we are physically meeting after a long time. After we are collaborating since I think for the last 6 years, but this is the first time we are physically meeting. And the foreign faculty of our this Gyan course, Dr. Anup Keshri, our Associate Dean Research and Development of IIT Patna. Dr. Anup Kumar Singh, Professor in Charge Gyan of IIT Patna, and Dr. Arijit Roy, the nominee of the head of the Department of Computer Science and Engineering. So, ladies and gentlemen, and all the students who are participating in this Gyan course. So, this is Gyan is a very new program, not a new program. This is the second phase of the Gyan. This is a transformative program launched by the Government of India aimed to enhance the higher education by tapping into the global talent pool of scientists and entrepreneurs. So by this GAN program, we can invite some foreign faculty to our campus, and they can deliver some 5 days and 10 days courses, and our students and faculty members can get benefited by this particular course. So this way, we can establish some collaborations with the foreign faculty and some foreign universities. So GYAN is a very good initiative by the MHID and the Government of India. So this GYAN course, the main theme of this GYAN course is temporal information retrieval. And in this 5 days GYAN course, Professor Adam is an expert in the information retrieval field, and he will deliver the lectures on this information retrieval. And you will get to know, starting with the basics of information retrieval, you will get to know what is happening in the temporal information retrieval field. So as you know, that temporal information retrieval is a specialized area within the information retrieval that addresses how the time affects the relevance and retrieval of documents. So this TIR primarily focuses on how time influences the information retrieval systems, because time is the most vital factor. Like Wikipedia pages, we keep on updating. No, like whatever we are seeing now, maybe a few years later, there was a past data. So how the data is keep on updated in the Wikipedia pages. So in this particular course, Professor Adam and also I will be taking some classes. We'll mostly focus on how time influences information retrieval systems, addressing challenges such as dynamic content processing, temporal query analysis, and time-aware ranking. Key application, this temporal information retrieval has many applications like future event prediction, temporal clustering, temporal summarization of search results, enhancing user experience by aligning search outcomes with temporal relevance. So I hope you will enjoy this 5 days course, and you will get to know starting from IR to TIR, temporal information retrieval. So let me formally introduce our foreign speaker, Professor GYAN, Professor Adam. So he is a distinguished professor and head of the data science group at the Department of Computer Science at the University of Innsbruck, Austria, where he also serves as the deputy head of the Digital Science Center. His research focuses on text analysis, natural language processing, and knowledge extraction from temporal document collections, with significant contributions to comprehension-focused search and retrieval augmented large language models. Professor Adam has held various academic positions, including associate professor at Kyoto University, Japan, and visiting roles at institutions such as National Institute of Advanced Industrial Science and Technology in Japan. He holds a PhD in Information Science and Technology from the University of Tokyo and has published extensively in prominent conferences and journals, receiving several prestigious awards for his work in computational history and digital libraries. So Professor Adam has been actively involved in organizing conferences and workshops related to digital libraries, information retrieval, and computational history. He also serves on editorial board of several academic journals. So recently, he is one of the influential papers. He has authored many influential papers in the field of IR. Notable publications include By Time BART. You know that BART is a very popular architecture in NLP, and we are popularly using BART as a transformer network for encoding our data. So this By Time BART is a very influential paper, which is the extending pre-trained language representations with dual type temporal information, and also archival QA, a large-scale benchmark dataset for open domain question answering over historical news collections. These are two SIGIR papers. SIGIR is a A-star conference in the field of information retrieval. And also there is a paper, Event Occurrence Data Estimation, date estimation based on multivariate time series analysis over temporal document collection. So these three are consecutive 3-year SIGIR papers, and which are some influential papers in the field of information retrieval. So Professor Adam has received several prestigious awards and grants, including Friedrich William Bessel Research Award by the Humboldt Foundation, an International Excellence Fellowship from Kulhur Institute of Technology multiple grants from the Japanese Ministry of Education for various research projects. So yeah, we are very much fortunate to have Sad with us today as our foreign expert. So I hope that you all will enjoy this particular course, and I hope this course will be useful for all the participants, and you will get to know the cutting edge technologies related to information retrieval and also the temporal information retrieval. And I wish you all a very safe and enjoyable stay in the campus and enjoy this course. Jai Hind. Thank you.
Thank you, Shiparna ma'am. I am delighted to extend an invitation to the Associate Dean of R&D, Dr. Anup Kesri sir, to enlighten the students about ongoing research and development endeavors at IIT Patna. Over to you, sir.
Respected dignitaries on the dais, Professor Adam from University of Innsbruck, Austria, Dr. Amit Kumar Singh, Gyan Coordinator, convener of this Gyan course, Dr. Shiparna Saha Madam, and in charge of CSE Head, Dr. Arijit Roy, and all my participants. Good morning to all of you. So I really welcome you all in the campus of IIT Patna for this 5 days course onto the TIR for this Gyan course. And I'm very happy to see that when I came to know about the achievement of Professor Adam, we are really blessed that we are sharing the stage with him. And I'm very sure that the next 5 days courses, what we'll be learning from him, it will be our eye-opening. Now, let me tell you about research and development activities, whatever it is happening at IIT Patna, since I really wish to share with you, Professor. And about the research work, what it is happening here is that a lot of the work is going into the top-notch research papers. Now, when we talk about the top-notch research papers, means if we see that the work, whatever it is getting published, it is in the Nature journals, in the advanced materials, in the IEEE journals. I'm not very sure about I don't know about many journals from the computer science engineering, but I keep hearing about a lot of achievements from the computer science department. Now, I'm happy to share that from the computer science department, a lot of the global collaboration is happening with the Google, with the Sony, Volvo Research, and many number of like this. I know few of them are like from the Tata Steel, Tata Motors, then again Cummins India, and most of the national agencies, whatever we can name for, we are collaborating with them. Now, let me apprise you about that, how much the funding we have received since the inception of IIT Patna. The total funding of IIT Patna since 2008, we have got or crossing more than 500 crores. It's a very big number, and all this funding has been brought by our faculty members, and where the staffs are helping them and research scholars are helping to all the faculty members, and these funding has been brought from the national, international agencies, from the government and the private. We are continuously signing a lot of MOUs, as I said that a lot of the companies. Now, when we are signing the MOUs with the companies, it shows that we are not only doing the fundamental research, but also trying to take this research from the lab to the market and trying to do the commercialization. When we are doing this, very first we are doing by step. So step by step means that when we are doing the lab research, then we are filing the patents onto this, then technology transfer. You will be happy to know that we have filed more than 95 numbers of the patent. And if you see that the number of around 47 patents has already been granted to the IIT Patna. So our numbers of the patent filing is increasing day by day, and hope we can keep doing well again in the future. So with this, I really wanted to stop here and give you all the best for this 5 days courses. Thank you so much.
Thank you, sir, for your valuable words. I hereby extend an invitation to the Gyan Professor in charge, Dr. Amit Kumar Singh, sir, to enlighten the students about the objectives, undertakings, and expected outcomes of the Gyan International Winter Course. Over to you, sir.
First of all, thank you, Shripanam, for organizing such type of event as part of GAN. And particularly the topic, this is so important topic at this point of time where data is everything. And tampering the data in so many ways at any of the platforms is one of the major challenges which industry faces every day. So this particular one becomes more and more sensitive as far as individual security, the data implementations, the data privacy, and other approaches are concerned. And hence the topic is very much perfectly aligned as per technological development of Government of India and their various initiatives are concerned. Government of India have a very strong focus on developing strong technologies, indigenously developed, with strong collaboration having with our international collaborators. And for fulfilling that, Government of India, particularly Ministry of Education, have this initiative, GAN, which we call it as the Global Initiative for academic networking to get excellence, particularly in the field of academics, research, entrepreneurships. And that ultimately leads to standard product level development, which will be and which is useful for the society for in general uses. As per this particular program, it is particularly supported by Ministry of Education, and the grants. This particularly supports the travel of our international guests as part of international collaboration. Now, this initiative also pushes our students residing in the geography to come up to learn with the experts, not in-house experts, also globally renowned experts like our professor, who is our main guest for this particular event. So this GAN course, as part of Ministry of Education's initiative, gives you a very strong platform to develop your technical skills, at the same time, your own collaborations for your future perspectives. So particularly to the participants, students, and for we faculty members and young researchers as well, we hope to develop our collaboration skills, learning skills, and to utilize the GAN resources to make it one of the successful events and one of the successful program for Ministry of Education's Government of India. By this, again, I will request all the participants to enjoy this 5 days moment, this talk. And particularly, I would like to thank Professor who traveled from Austria to India and is giving his too much important 5 days of time. I will request Professor to enjoy our country, stay and enjoy our welcomeness and our environment, particularly the Bihar, one of the most historical places in India. So by this, thank you all of you for joining. Thank you.
Thank you, sir. It was truly insightful. I would now like to invite Dr. Arijit Roy, sir, to provide the students with valuable insights into the department's initiative and activities. Over to you, sir.
Thank you, Sarmishta. First of all, I would like to thank to Professor Adam for coming over here and in helping this course on this information retrieval. And I would like to thank to Kesri sir and Singh sir for supporting us, and obviously Sripanna madam for conducting this course. And on behalf of Professor Rajiv Mishra, our head, Department of Computer Science and Engineering, so I am present over here and I am trying to give you a few glimpses of our department.
So our department has diverse, all the faculty members, they are from the diverse research background, including this information retrieval, machine learning, deep learning, then generative AI, fog computing, cloud computing, Internet of Things, then quantum computing, computer vision. So many faculty members are working towards different research problems, and all the faculty members, we have all total around 18 faculty members currently in the department, and I would say all the faculty members, they have very nice research and academic profile, and they are working towards different research projects. They are conducting different these courses also, which are really useful for the real life application and implementation. And we have two BTech courses. One is in computer science and engineering, another one is AIDS. And along with that, we have MTech course on computer science and AI. So we have a very good number of students currently, around 1,800 or so. I hope all the participants, you will enjoy this 5 days, this GYAN course, and I would like to thank to the government of India for providing us this sort of opportunity to conducting the course like GYAN. So thank you. You enjoy the course. Thank you.
Thank you, Dr. Ranjit sir, for sharing your valuable insights. Now I would like to invite Professor Adam Dandor to shed light on the current advancements in the field of temporal information retrieval and share insights with our students. Over to you, sir.
Oh, can you hear? Okay. Good. So I would like to thank everyone for coming here. Very happy to be here in India at IIT Patna. And I'm very honored to be selected by the GYAN program. And I would like to thank to Professor Siparna Saha and all the faculty for great hospitality. I'm very much impressed by the university. I have to say it's quite large, really large compared to European standards, very new buildings and a lot of very motivated students. And I also like very much the greenery here. It's wonderful. It's very nice to be here. And personally, I have been in Asia for about 2 decades. I stayed most of my career in Asia, in particular in Japan. Now I am based in Europe, but I'm very happy to continue collaboration with Asian countries to expand farther from the Europe, because Europe sometimes is too much closed, too much grants are just for European countries, and we lack this sort of opportunity to connect with the rest of the world. And in particular, I also want to thank to Professor Siparna Saha for our continuing collaboration over many years. We have co-supervised many students, we have submitted many papers, and we applied to this GYAN program to have a chance to meet in person and talk to the students. The first application was rejected, and I thought, like, we spent so much time on that, and I thought maybe it's impossible to get accepted. I lost my faith, but Professor Siparna Saha is a very challenging person, and she said, no, we have to try again. And then we greatly revised the application together with some of the students, and it got accepted this time. And I hope to strengthen the collaborations and also talk to many of you. So if you have any research in mind, any idea, feel free to reach me after the lecture, and we can discuss. And maybe I can give you some enthusiasm or some advice and encourage you to pursue your dreams. About the course itself, I think information retrieval has gained a second life now. It was popular for many years, then it was a little bit overshadowed by natural language processing. But with the RAG developments, where you need access to the database and retrieval of the data, information retrieval is getting, again, I think, wind into its sails. So it's very important to, on time, and quickly, efficiently, effectively retrieve information and supply to large language models, because large language models are always trained until certain cutoff time, and they need access to fresh information. And about the time temporal aspects, obviously, information in the current world quickly becomes obsolete. It is losing its importance, its relevance, so you need to always pay attention to time. When information was created, is it still valid now, and how it changes by the context change, and so on and so on. So I think temporal aspects are greatly important in a fast-changing world. Access to the information resources by information retrieval, also super important. And large language models these days, I'm sure many of you use them, are super helpful. And I think it's maybe a chance to communicate with machines these days by large language models. And machines can communicate in our language using large language models. So it's a kind of like interface between many machines, and I'm not only talking about LLMs. It could be any AI system that can now connect with humans in a better way, because through the conversation, through our means. So we use LLMs in our university, not just per se, but also to connect to some energy systems, to make decisions, to help writing reports. They are now becoming sort of like a glue, I would say, and connecting factor between AI and humans, and facilitating, of course, transforming our life and our work. So I hope I can give you some insights on LLMs, on information retrieval and natural language processing field, and maybe give you some enthusiasm to submit papers to good conferences, good journals, and excel in your research. So yeah, as I wanted to also say, concluding that it's not only a chance to learn something from my lecture, but also a chance to connect, exchange ideas, start new collaborations. And I'm very happy to be here and have this opportunity. So once again, thank you all.
Thank you, Professor Adam, for sharing your valuable knowledge with us. At this juncture, it is my privilege to invite Dr. Shiparna Saha to extend her gratitude and deliver the vote of thanks.
So yeah, so it's now the time to give the vote of thanks, because we are at the end of the inauguration ceremony. So I place on record our deep sense of gratitude to the Ministry of Education and the Government of India for granting us this GYAN program, which is an ideal platform to tap the the talent pool of international scientists. And we also gratefully appreciate the help and the support that we have received from the Institute administration, especially from the Office of the Directorate, Guest House, the Office of the Research and Development Unit, the Office of the Registry, and etc. And I also thank the GYAN, the PIC GYAN, and also the Associate Dean Research and Development for all kind of supports. And also all the student volunteers of this GYAN program for helping me throughout this process for organizing this particular program. And heartfelt thanks are due to Professor Adam, who accepted our invitation to be a part of this proposal. And he is one of the very well-known scientists, as I already mentioned, in the field of information retrieval. And I hope you all will be, learn a lot from this 5-day course on this temporal information retrieval. And he agreed to come to India to deliver this course. So we are very much grateful to you, sir. And this workshop would never have been successful without the participation of the undergraduate, postgraduate, and also some research scientists from various corners of the India. Some of them have not yet reached, they are on the way. So their participation, I am sure, will add depth to the content and deliberations. Thank you all for coming and participating in this GYAN course. And an event of this magnitude requires meticulous planning and execution and an eye for details. And I have been extremely fortunate to be able to draw upon the willing support of all my volunteers. So it's very difficult to name all of them. But, without the active team of volunteers, it's very difficult to plan this kind of 5-day course. So I wholeheartedly I must place on record the appreciation of this entirely efforts of all these AI NLP ML team members. So finally, thank you all ladies and gentlemen for joining us on this occasion, and please enjoy this 5 days course. Jai Hind.
Thank you, Shiparna ma'am. To the students, I encourage you to seize every opportunity this next few days present. Thank you for being a part of this momentous event. Let the Gyan International Winter Course be the catalyst for a transformative learning experience in 2024. Wishing you all an intellectual, stimulating and rewarding time ahead. Thank you. Ladies and gentlemen, I kindly request everyone to stand in honor of our national anthem.
Okay, thank you so much. Thank you so much. Yeah, thanks for coming. Take it, madam. Thank you.
Sir, I'll give you in a back.
आपके लिए कृष्ण लोग क्या ये आपके लिए स्पेशली लेके आए इसलिए मुझे गुस्सा हो गया कि आपको लेके Oh, there is a this a manual like it is artist. Sir, make original. So one of my biggest supporter in the department is my neighbor also. So we used to gossip a lot. So yeah, he is in the department. Yeah. So just joined last year.
In computer science.
Yeah, in computer science.
What do you work on?
Mainly on IoT, Internet of Things.
Internet of Things. Okay. Important these days.
Yes.
Smart
But
University.
along with ML.
Sorry?
Along with ML.
Yes, as a connecting factor. Good, good.
Yeah. So we'll chat maybe later on.
Yes, yes.
I guess you can share, right?
I hope so.
Sir, he is one of the senior faculty from the electrical engineering department, Professor Pitam Kumar.
Welcome to
Yeah.
Patna, IIT Patna.
Yeah. See, he is the one of the founding members of IIT Patna.
Okay.
Like IIT Patna was established in 2008. He joined that time.
16 years ago. That's still young university.
Yeah, yeah. So he's here from there, then that time.
Okay. So you're founding father.
Founding member, I can say.
of the university.
It's great that you have come to IIT Patna. Definitely our students will be
Yes, but yes, yes.
बोल दिया
I hope that's
हम
gonna be
हटवा देंगे चेयर
discussions.
बाकी सर अपना लैपटॉप
So we can
पढ़ाएंगे
take now.
स्लाइड इसमें ट्रांसफर
We have some.
ट्रांसफर करवा दे गाड़ी में गिरेगा नहीं
At least, hopefully.
On syllabus could be much more than this. Exams are going on, so.
Of course.
And some
But
exams.
this is online. question.
Yeah, there are some online
Online.
classes. It's hybrid also, yeah, online.
Okay.
Yeah, so it's both testing.
Yes, yes, yes. Let's go for
These
it.
were young faculty, right?
Yeah, and guest.
Youngest.
How many faculty you have?
Total we had 187.
But in all Patna, you mean IIT?
I do not.
But how about computer science?
18, I think, now.
We have sort of faculties in computer science. Very difficult to get good faculty in computer science.
Yeah, because industry wants.
University, yeah.
But 18 compared to other? Oh, it's less than others, so you have to grow that, right, to extend more.
Minimum it should be 35.
35.
Most of the strength, because they are running two BTech programs.
Yeah.
One is computer science engineering, other is AI in data science.
Kind of national funding. Now AI is so important, right? Computing is so important. Growing. But 18 is already right.
और सर हम
Multiple rounds are going on. It is very tough to get into IIT.
अभी तो उनको बताएं कि कैसे आवाज
You need to put in fundamentals, research, projects, so many things they want. Because once you join an IIT system, you have to do teachings for most. Then you have to bring a lot of sponsored consultancy projects. Then you have to do a lot of administrative works. So one should be generally assess then all the parameters. If fit, then only they.
It cannot be just a research.
Yeah. Everything.
Teaching, grant management, student supervision.
Student supervision.
How easy to find a good person.
Lucky to have.
She's a shining star.
Yeah.
So Sir was for a long time in Japan, Poetry University.
Poetry.
Yeah.
नहीं तू निकाल कर दे हाँ कॉपी कर दी और वो रिकॉर्डिंग चल रहा है ना ऑटोमेटिक बीच में स्टॉप किए थे आप बोले रहे एक बार देख लीजिएगा अभी जस्ट 2 मिनट के लिए नहीं अब तो रिकॉर्डिंग चल रहा है रहने दीजिए रिकॉर्डिंग सही है वो हम स्टॉप किए थे स्क्रीन शेयर से हम स्टॉप किए दो कुर्सियां रहेंगे सर 2 कुर्सियां रहेंगे हाँ ठीक है दो चलेगा
ये हटाइए
अच्छा ठीक है
You will be staying here?
Yeah, I have also registered, sir.
Oh, okay. This is for changing, right? Okay. No, I think it's okay. Water, yeah, this is not mine, but later.
Yeah, we are bringing some.
Oh, different. Good. So can we start?
Yeah.
Okay. Yeah. Thank you. Thank you for all the comments. I hope I am audible. You can hear me well. And before I start, anytime if something is unclear, just raise your hand and ask questions. What's important is to make sure everything is clear. And well, if you have some even related question, we can always stray away from the main topic and discuss something interesting to you. So when I want to start about information retrieval, it's these days it's actually quite useful to start with natural language processing, because information retrieval relies on many findings and knowledge from natural language processing. But before that, we maybe remove this one. All right. So before I even start with the material, I want to say a few words about myself. So I am now in Innsbruck, in Austria. Innsbruck is, let me just come back again here. Innsbruck is located just here when the arrow shows. We are between Germany, next to Switzerland, and very close to Italy. So we have many international students coming from Germany and coming from Italy. It's one of the most internationalized universities in Europe. And we are even closer to Munich, which is somewhere here, than to Vienna, the capital of the country. So we have to take 4 hours to Vienna, but only 2 hours to Munich. So for us, German city is even more important than our own capital. This is the old building of the university. It was founded in 1669. It's not that old like some of the universities in India, as I heard. Very old ancient universities, and some universities in Italy especially, but it's reasonably old. We have some, of course, modern buildings, not just this historical building, but this is a campus of humanities, politics, and social sciences. As you see, the city is actually in the middle of very high mountains, so we have a lot of tourists every day. Skiing season starts very early on because we are high in the mountains, so it starts already from something like September, even October. You can go to the where the high mountains are and do the skiing until April. And this is the most picturesque part of the city, this line of houses and the main square. So I am now in Innsbruck, as I said, but only from 2021. All my career I did in Japan. I was a student in University of Tokyo, and then mostly in Kyoto University, I was assistant and associate professor. Actually, these two universities are considered as #1 and #2 university in Japan. So we have also many international students and quite well-known, well-connected universities. What I work on is mainly text, analysis of text, like working with news articles, working with social media, and even sometimes with old news archival research topics. And some recent topics that I was working on are listed here. For example, we work on answering questions, but questions about temporal topics from news archives. We do timeline summarization. I will talk about it later on, probably tomorrow. Of course, search and recommendation models for information retrieval, we are working a lot. And there is also a topic of text readability and comprehensibility. That means how easy is to understand the text for user. We have to guess. In this research topic, can user understand this document? And how would you do it? Right? You can consider the length of sentences, the length of words, but it's not enough, right? You probably need to consider how specific are terms, how much domain knowledge do you need to understand certain topics, and so on. Even we also did a route navigation, so because Google, when you want to walk, let's say, from here to maybe Patna, right? Google can suggest you the fastest route or the shortest route, but what about the route that is most interesting, right? Or more greenery is there. You don't go through some areas of factories or something, right? Google is not providing this facility, but we supplemented this by giving a choice to users. For example, when you go to USA or some other country that sometimes is not very safe to walk on the street, and maybe you are the first day there and you don't know the city at all, you're going outside, you may choose a wrong place to walk. It might be even sometimes dangerous, right? So we also provide route recommendation based on safety. Walk through safe neighborhoods where there is little drinking, little drugs, and so on. You may try to find information on that through the web, but the web will not tell you how to walk from place A to B through the safe neighborhood, right? It's not that clear. So we also worked on that. And recently, one of my students started a new topic, a hint generation. And I really like this topic because it's very educational. So LLMs are good at making answers to questions, right? LLMs are also used to create questions, but there is no research to create hints for users to answer questions. And we think that in the future, LLMs will be even more powerful. Everywhere you will have ready information, good information, right? But what about human? Human will just ask question and get answer and don't think, critically, don't do cognitive thinking. So we are thinking that actually we should give hints to users so they are still thinking, they are using their brains, they are connecting facts, critically thinking, in order to keep still user at a good level of cognitive reasoning. But how to generate a good hint? What it means, a good hint, right? Hints should be not too long, maybe not so difficult also, right? But at the same time, it should converge you to the correct answer for your question, right? But how to quantify this convergence, it's what we are now researching, is a new task. In addition to question answering, question generation, we propose hint generation, like in the middle between the two. Sure, there is some noise, but I don't know if, yeah, probably I'm moving too much. I will try to be still. Yeah. So about this course, sorry for a lot of text, but this is just a copy from the document introducing the text. In short, it is about a way to extract information using LLMs or using web search engines. And it is about not just semantics, but also temporality, whether information is up to date, whether it's changing, valid, obsolete, and how it relates to a given temporal context. There will be also about reasoning. We'll talk about common sense reasoning of large language models. We'll talk about answering questions, but temporal questions in particular. And we'll talk, of course, about large language models and web search engines as well, and the temporal aspects of those. So this course is a mixture of many related topics, mainly NLP, natural language processing, and information retrieval. And objectives is to give you fundamentals of IR, information retrieval, fundamentals of NLP, and also this notion of how time aspect can be utilized in these two fields. So this is the schedule, but as I discussed with Sriparna, we may do some changes. I think this will be announced maybe later on. So today I will talk a little bit longer, maybe 3 hours today, and tomorrow as well. And then on day 3, mainly Sriparna Saha, Professor Sriparna Saha, she will talk, and the rest, again, I will be talking. As you see, the topics are related to natural language processing, the basics, fundamental aspects of text processing, LLMs, information extraction, question answering, information retrieval, and also common sense reasoning, temporal common sense reasoning. But as I said, this is just tentative, so we can do a little bit of the changes. Let's see how it goes. But overall, this is the structure, the kind of stuff. And now I will want to start with natural language processing. So let me maybe ask, how many of you are working in natural language processing field, doing research, not just checking ChatGPT, but actually doing research? Anyone is, right? So I know already the students of Professor Sriparna, obviously. But many of you, maybe it's good to give some background, introduction. So I hope in the first hour, maybe a bit longer, we can have this introduction. So the human language is a general purpose communication tool. We communicate with other humans using language, and also these days with LLMs. And natural language processing is a very technical field. We have a field called linguistics also, but the difference between linguistics and the difference between natural language processing is that the second one is more technical, more related to some tasks, solving concrete particular problems. And well, natural language processing deals with methods, algorithms to take as an input and produce as an output unstructured natural language data. And this involves all the computational algorithms and representations for processing natural language. We often talk about three, I would say, major types or segments of natural language processing. It's a syntax, semantics, and pragmatics. Syntax means anything on the lower level of text processing, right? Ordering of words, the grammar, the meaning. If you have the two sentences, the boy beat the dog beat the boy, the difference is obvious, right? But this difference is, well, first of all, on the syntax level, right? On the shallow level, and this difference later is actually arising to the semantic level, which is here, the level that concerns the actual meaning of words, not just their ordering, not some grammatical connecting words, but the actual sense of words. That's the semantic level. So syntax, the basic, the structure, the grammar, semantic, the meaning, and pragmatics is the last part of NLP, which deals with context, the effect of context on a sentence. If I say the first sentence, the ham sandwich wants another beer, right? at the party, for example, the context is obvious, right? Someone needs a bit more, sorry for the alcohol example, but I think this is very contextual sentence. Or John thinks vanilla, right? How would you understand this sentence? John thinks vanilla. How would you interpret this sentence? Does John want to eat vanilla, right? Or vanilla ice cream? Or if this is, let's say, some kind of discussion, on the research, and someone says he thinks vanilla, the understanding would be that his ideas are very plain, right? Not very, let's say, advanced or complex. He wants basic solution. So you see, the pragmatics is also important at the context, at the time for also, at the situation, at the place when you issue or maybe receive some language statement, some text statement. So now I will give you examples of NLP tasks, starting from simple ones, low-level syntactic tasks, and then going to semantic tasks and pragmatic tasks. And as I said, NLP is very much oriented on tasks. It's a very technical field, engineering field. It's not like linguistics, studies, theories, how language is formed or how people communicate. It is solving concrete problems. So one problem, word segmentation, right? The problem means you have a string of text, characters, and you need to divide it into words. Quite easy in English. It's not that difficult in English, right? You just use white spaces, which means anything separating, words like this. But what about Chinese and Japanese? Well, you need a bit more clever solution to divide a string in Chinese, Japanese, and I guess also in India, Hindu, right? I'm not entirely sure how to do word segmentation in Hindu. Do you have white spaces? You have, okay. So situation is a bit easier. But for Chinese, Japanese, it's a continuous string of characters. How can you divide this string into words? You can use dictionary, right? Just you start from the left, go over the text, and check always dictionary. You take the longest segment that is in the dictionary and make a pointer. Then again, look for the longest segments that is in the dictionary and make a pointer. And by this you divide. But actually, it not always works well because dictionary is obsolete, not always changing that fast as the language, and much better is machine learning. So there are machine learning solutions how to divide things. But even for English, you need to do division in a more, more complex way than just looking at the white spaces. Like if I want to parse this URL or this one, I don't have white spaces to separate it. I need some kind of knowledge. And sometimes it's not easy. Plucker swing bar could be understood as Plucker's wing bar or Plucker swing bar. It's a kind of, maybe you need a bit more processing. Maybe I will just remove this one. It's really making a lot of noise. Since I'm not walking so I think, it's better. Okay. I hope it's fine. Yeah, I'm not even touching it. Yeah, it's better. Okay. Right. So word segmentation. Another task, morphology analysis. Morphology means studying how the words are structured. What are the components of words, so-called morphemes? It's the smallest linguistic unit of the word. The word like carried can be decomposed into carry and ed, or independently can be decomposed in, depend, and li. The parts of words which happen in also another words, right, which are repeated. And one of these morphemes often is a central morpheme, like depend, the most important morpheme in the word, which designs the meaning of the word. In is modifying the meaning as negation, and an ly also modifying to become adjective or adverb, but depend is a central morpheme. So sometimes you may have even a problem how to parse this. Is it unlockable, something that cannot be locked, or something that cannot be unlocked, right? Depending how you see it. I just want to show you that it's not always that easy to just divide a word into morphemes. But that's one task, right? To do morphological analysis of words. Another task in NLP, quite common, is a part of speech tagging. So you take the string like I ate the spaghetti with meatballs, and what machine needs to do is provide the labels here, which tell what is the role of word in a sentence. Is it a verb? Is it a determinant? Is it a pronoun, a preposition, and so on? It looks easy in the first example, but the second example, you see that so and another so have different part of speech. One is a verb in past tense, and one is a noun. So it's not always that simple, but if you do this kind of labeling, the next stages of NLP could benefit from it, right? Question answering, translation, because you translate so in a different way, this so and this so, obviously, right? When you translate to Spanish, this sentence. So this knowledge can be useful for many other downstream tasks, not just per se, it could be useful, but can inform other next subtasks. Phrase chunking. What we can do is we can group now words together into phrases, noun phrases or verb phrases, right? So the current account deficit could be considered together. This is one noun phrase. Will narrow, another phrase, this time a verb phrase, and so on and so on. You can do actually a tree based on such grouping into noun phrases, verb phrases, preposition phrases as well, and so on and so on. A complex sentence like this one could be decomposed. Again, this could be useful for translation, for question answering, for retrieval, because you consider the words as grouped into one phrase. So it could be easy to handle a user query that is also maybe in the form of a phrase. And further on, syntactic parsing, so building this grammatical tree on the syntactic tree on the sentence is another task. Now, what about a semantic tasks, right? Not just syntax, not grammar. Now we go level up. What are the common natural language processing semantic tasks? So word sense disambiguation is one of them, which means assign a meaning to the word in context. Like here, the word interest here and in another sentence have a different meaning. The first one is just a hobby, just a curiosity. The second is obviously related to financial topic. Now for the machine, it is still a string of characters which happen to be exactly the same in these two sentences. So the machine needs to assign a proper meaning to these two occurrences of the word, the meaning which can be taken from a dictionary. In a dictionary, we should usually have all the senses of interest and other words. And now we need to just assign, is the first sentence the first sense or the second sense, or maybe there could be more senses. Some words are really polysemous and have many senses. It could be more than 9, more than 10. The word like back or that could be in many different senses. But that's the task for the machine to do it. Again, could be useful for many other downstream tasks, summarization, translation, question answering, and so on and so on. Now, if you compare this task, word sense disambiguation, to another one, which I talked before, part of speech tagging, how would you say, which one is more difficult? Part of speech tagging or word sense disambiguation? Anyone has a guess? The two tasks are actually classification tasks, right? You have a word, you need to decide a class. Another word, decide a class. Which one you would say is more difficult? And why? Anyone has a clue? Except Professor Saha, of course. She knows the answer. So I will tell you, this is simpler. Both are classification, but this is simpler. Why? Because the number of classes is limited here. You have about 45, sometimes 90 classes of part of speech, but it's fixed. We have only adjective, adverb, noun, pronoun, a finite number, and not that many. right? So small number of classes and fixed for every word. Spaghetti, we choose out of these 45 classes. Meatballs, again, we choose out of 45 classes, happen to be noun for both of them. But what about the word sense disambiguation here? Interest might have two meanings, but perhaps pace can have many meanings. I pay a visit to someone, I pay money, I pay interest, right? Or pay attention, quite many different meanings. And it changes for every different word. You might have a different set of classes, 2 for one word, 5 for another word, and different ones. So it's more complex. This task than part of speech tagging. Anyway, both are classification tasks. Now, semantic role labeling. What else we can do with text? Well, we can give labels like this: agent, patient, source, destination, instrument. A John is an agent in a sentence that is giving or doing something to a patient, that is a Mary. There could be also some moving action from a source to the destination, or vice versa. Well, not vice versa, but these two, and the instrument. And the second sentence is quite interesting in such a labeling scheme. Why is it interesting? Because you have a subject of the word, of the sentence, being an instrument, right? So the hammer broke the window, but why it's not an agent? We know that hammer cannot move itself, right? So with our common sense, we still know that the subject here is an instrument, which is rather very rare case, right? A subject should be usually a kind of, well, human being or animal, but not an instrument. Anyway, you see that it's not always that simple or that obvious. And this kind of understanding of a text by assigning the labels here could be really useful for, again, translation, question answering, common sense reasoning, especially, and so on and so on. And you can do this in a very simple way using tools like spacing, basically one line of code, and then you will know where is the patient, where is the instrument in a sentence. And could be useful, for example, for summarization. I may need information about instrument. I just need information about agent and patient when I summarize a text, so I can do shortening of the text by removing, let's say, instrument or even destination and source information. Well, not always, but often we can do that. Now, textual entailment, another task, a semantic level task. And this task is quite old. It's not very new. It basically means, given the pair of sentences like this text and a hypothesis, please tell me, is it true or is it false, right? So does it mean that the first sentence logically implied a second sentence or not? You have two classes. And you see, this is a deeper level of understanding of the text. It's not just grammar. It's not just word sense disambiguation. It's moving even higher, right? And you would agree that the first pair of sentences are logically true, right? The first sentence is about Yahoo taking over another company. And you can just shorten it, Yahoo bought over two. So they are logically equivalent, these two sentences. But the second one is quite interesting. Microsoft is the subject here and there, but you see that, well, at least it's a word that starts a sentence, maybe actually not a subject. But you see that another company, Sun Microsystem, actually bought Start Office, not Microsoft. So the label here should be false. But a very simple tool which just looks into the first word of two sentences can be mistaken and say that they are equivalent, but actually not. And so on and so on. And this task can have another label, not just true or false, but as you can guess, another label can be just neutral. You cannot tell that one sentence is implying another sentence. They are not contradicting, they are not implying, but just not related. Then we would have yet one more label, a neutral. Like here, basically. You have example of text entailment, now with three labels, three classes. And it's actually called by another name, natural language inference. It's another name for textual entailment. So there is logical relation here. One is entailing another. There's contradiction. These two sentences are not equivalent. And now in neutral case, we cannot tell which one is logically implying. I mean, if the premise is logically implying hypothesis. And we have extended this problem, natural language inference. I will try to move this one even farther somewhere. Okay, maybe here is the best. So we extended it to a temporal variant of natural language inference to provide a time-related inference. So if you have these two sentences, I'm cooking pasta bolognese for the first time, and the water is not hot yet, the task is to tell whether the second sentence is implying the end of action expressed in the first sentence, right? And you would say not. S2 means that S1 is still going on. The action is still going on. But S2 in the second case, the second pair of sentences, you will imply from a common sense reasoning that S1 is no longer valid. The sentence finished, right? It's obsolete now. If I see it on the Twitter, I should not understand that the user is still cooking because there is a follow-up sentence which nullifies the first, the validity of the first sentence, right? So we propose setting up a natural language inference in a temporal fashion. And we published a paper on that and moved on to make this task even more complex by adding context and so on and so on. I will talk about these problems probably in the last day of this lecture. And you have some example here. Again, for example, the last sentence, a man jumping a rail on his skateboard and his favorite food is pizza. We don't know if the second sentence stops the previous action or continues the previous action. We don't know because it's just about unrelated to the action, so it's unknown. But supported, invalidated are the other levels that say the action is still ongoing, supported, or the action finished, invalidated. The parallel to textual entailment would be that supported means true, so entail, and invalidated would means false, nullify, or cease the action. Okay, now we move on to even more complex tasks, pragmatics tasks in NLP, and discourse analysis. So one of them is resolution or co-reference resolution. If I have a sentence, John put the carrot on the plate and ate it, what would you say this eat? What does it mean? What word it relates to? Does it relate to plate or to the carrot or even to John, right? Probably not to John, right? Because John is he or it could be she, right? If it's Mary. But does it relate to plate or carrot? Plate is closer to eat, right? So by the vicinity, sometimes machine may actually be confused and say that relates to plate, but obviously it relates to carrot. Now, what about the word like president here? It is, as you see, coming to the previous sentence, so it's a between sentences relation, a co-reference relation. Which word is this president defining from the previous sentence? Obviously, it's Bush, we know. But if you look at the last example, and I ask you about the word it here, where this it relates to, which other word it actually represents. Is this the word kite here, or is it the word kite here? Actually, there are two different objects in a story, right? And you will see that it actually relates to this kite, not to the more recent, closer one, right? So this resolution of a references of anaphora, as you see, is not always that simple, right? You need a story understanding. In the second, the last example, you need a story understanding to properly tell to what this it relates in a sentence. Then ellipsis resolution. Do you know what is ellipsis in a natural language? Do you know this task, right? Anyone knows? So if I have this sentence, which was spoken by a Greek philosopher, Plato, wise men talk because they have something to say, fools because they have to say something. Now there is ellipsis because certain word was missing. The word talk was actually not present in the previous sentence. So there was ellipsis, omission, right? We just skipped one word because from our common sense understanding it's obvious, but for a machine, sometimes we may need to complement to, extend the full meaning of the sentence and provide information here, right? So resolution of the ellipsis means detect where is omission and also tell what word was omitted there, right? Like here, giving a talk to this sentence. Now, these were just division into syntactic, semantic, and pragmatic tasks. There are many more tasks which is maybe difficult to associate them to one of those three groups. I just call them, let's say, application-driven tasks. And I will go very quickly over them. One is information extraction. We can extract who is a person, who is organization, who is a place in a sentence, giving a label or even coloring them. And now this could be very useful if you want to collect all the information about, let's say, organizations mentioned in a news corpora. You might have a large collection of news articles in there. Now you want to extract all the organization there, and you can even extract relations between different components, right? So the task would be find me every CEO relationship in the news articles, and then you find all the names of CEO, you find all the companies that relates to them, and you can build quickly a database from some large corpora of news, database of CEO persons of different companies. That's information extraction task in NLP. Again, we have very good solutions. You just need Spacey tool, for example, one line of code, and you can extract all these different entities and even relations between them, which could be useful for your analysis project of text. Then temporal information tagging. You see, we are now extracting actions, and we are extracting also the temporal information, which one was before another, maybe at the same time or after or before, all these temporal relationships from a text. I will talk about it later on, so just briefly. And another task I want to present is a text readability assessment. As I said, it means whether text is easy or difficult for a human to read. It could be very useful in education. If a teacher wants to provide a reading material for second grade of elementary school, the teacher needs to make sure this material is easy to understand, as opposed to teacher who looks for university students materials for reading, or let's say 5 years down the education road students, right? So you need this assessment of how readable text is for a given person. And what you see here is a example of a system that my student built, a bachelor student, which it's for German, so it's not English. And you input a text, you click a button, start, and basically the tool is understanding each sentence and assigning a score here. You can see a small number here, which indicates how easy to understand is a sentence, from 0 easy and 1 to hard. And you might think, okay, very long sentence is probably very difficult, but it's not that simple. The sentence can be even short, but use such a difficult words that you will not understand it fully, especially in a given context. So it's not just length, but the choice of words, grammatical, ordering, logical meaning, and position of a sentence in a text, and so on and so on. How this tool was built? Actually, we use Transformer. We train Transformer on easy text and difficult text. And now, how could we get training data? How can we find easy text and difficult text? The easiest way is to go to the school. The first year of schooling, the second year of schooling, third year of schooling, you have many textbooks, very nicely divided, and then you can, let's say, separate into two groups, hard and easy, right? Maybe even removing the middle years, just not to have too much overlap, and you can train a system on that. And also some magazines, some journals have also easy version and difficult version. There is even something called Simple Wikipedia, which is supposed to be written using only 2,000 words, no more, and in an easy way. So we also have a lot of data to train Transformer, and this is the tool that was trained. There was no such tool for German, so the student did something quite new, and we published a demo at the Information Retrieval Conference. So sometimes you may not only publish a full research paper, but sometimes you can publish a short research paper or demo paper which introduces a system, how to build something working, which could be also of interest to the community. I don't know if something like that exists for Hindu, but I think if not, there would be a very good topic for making a demo or even a research paper if you have a data, but I guess from education, you can easily find some textbooks, right, for different schools. I mean, different year of schools, and then train a couple of different models and then see which one works well or not. So, and this could be useful for educations, but not only for educations. Actually, many companies, they are required to make simple text, especially for safety-related products. Imagine a child seat in the car. Right? How to assemble it, how to mount it. Well, we can't assume that everybody understands everything. So this instruction has to be written by law in a plain language, easy to understand language. And also countries like New Zealand, they introduce a law that every communication from government, from institutions, ruling institutions, must be in a simple language. So the politicians, the administrators need to always check their communication, their statement to the public, right? So, because it's a kind of democratic movement, we want everybody to be able to understand, everybody to be on the same level. So, it's quite important research topic, I would say. Now, question answering, the very popular task these days that LLMs are solving. We work on that too. We have been working on it before large language models came. That time, people always say, wow, this is fantastic. Now, of course, question answering, everybody thinks it's almost for granted. But if you look at the first sentence, it's very simple. It's a factorized sentence. You just retrieve information that is Wikipedia, that is anywhere listed. But if you look at the second sentence, who was president when Obama was born, that needs some inference, this sentence, right? May not be such an answer like Kennedy, easily given on the web. Well, I can ask about any president and any relation, and, well, you see, you may not find such a sentence just to copy it and give to the user. You may require a machine to do some reasoning. First, find when Obama was born, and then find who was the president at that time, right? So it's kind of two steps process. And the last sentence is even more difficult because you need to do a counting. And many question answering models are still not good, LLMs as well, in counting like that one. How many presidents were since Obama was born? But now imagine I put some Indian politician here, right? Maybe not that famous one of the, let's say, middle level of politicians, right? Or even from the past someone. Then LLM will not have any sentence containing such an answer, need to do the calculation itself. So we are working in our research on more complex questions, not that easy to be solved, and temporal ones. Then what did Obama teach, right? This answer, well, this question can be answered using Wikipedia, constitutional law, right? He was teaching in Chicago Law School. And if you have a task of taking a question like this, what causes precipitation to fall, and you have a context, you have a text given from which the answer needs to be extracted, this is also called reading comprehension, this task, not just question answering. Because if you are able to answer questions for a given text, it means you understood this text. And machine comprehension or reading comprehension is a variant of question answering where you have a given text and you need to answer any questions. This example It's taken from a squad data set. It's by Stanford, 100,000 question answer pairs together with context like this. There was one of the very first question answering, or I should say reading comprehension data sets, and very influential, used by many systems later on. Now, text summarization, we know what it means. In this case, you see a summary is very short and is abstractive, which means it has been generated from the scratch, this summary, abstractive. But you might have extractive summarization, where you need to find which sentence is good to pick up and create a summary, or a couple of sentences, but small number to summarize longer document. And up to, I would say, 2015, the research community was mainly using extractive summarization tools, which was a classification task. Go over each sentence and tell me, is it good to be included in a summary or not? 0, 1, right? Labels. Of course, you may pick up a sentence which is often at the beginning of article or at the end of article, because such sentences are concluding or summarizing the article. But it's not just the last and the first, they are also in the middle. It was still difficult, the task. But now when you want to generate from zero the summary in an abstractive way, it is even more difficult, but then you can generate very short summaries, question-dependent summaries. You have more flexibility, and that's what large language models do. They do abstractive summarization. Extractive example is here. You see now not one article is given to summarize, but actually a bunch of articles on the same topic. And the task, if you do extractive style, is to pick up sentences that together, glued together, can create a summary. And the problem with this extractive, what would you say? What would be the major, issue in extractive type summarization? If I just pick up sentences and combine them together, what the risk I'm having? What is the issue that can happen here? Anyone knows? A logical flow of text, right? The text may not be coherent anymore. You might have some pronouns, like for example, it, which in one text makes sense, but if you combine it with a sentence from another text, it's no longer fitting together, right? So extractive is simple to do because it's just classification which sentence is good or not. But if you stitch everything together, you may need another step, post-processing step, to make sure all these, pronouns and also the logical flow is taken care of in the text. Now, sentiment opinion analysis, a very useful tool for industry to understand what people think about products, persons, events, basically any name entity. And you can build tools like this one on a Twitter, where you input, let's say, company name or a politician or a movie, and you basically have some quantification, how many positive are opinions, how many negative, and perhaps the neutral. And you can pick up some representative tweet as well to give a context. What is typically negative? What is typically positive? And this is often called aspect-based sentiment analysis, where you give also some aspects to opinions. Then machine translation, another natural language processing task. I'm giving you many examples of the tasks, which is very well known. I'm sure you use it. Maybe some of you even every day. I'm using every day because I don't understand German, and I have to work in a university in Austria where people speak German. So I often copy and paste when the emails come. And these days, tools are very good for doing that, but not that good when it comes to Asian languages like Chinese, Japanese, the languages which have different grammar than another language to which you want to translate. If I do translation from French to Spanish, almost perfect. German to English, very good. But if I do Japanese to Polish or Japanese to Hindu, you sometimes will struggle. What is really the meaning? And one of my students, he's actually from Indonesia, is working on translation from the language called Latin to Italian and to English. And Latin language is interesting because there are only 20,000 speakers of Ladin, and they are just in one valley in the mountains. Historically, they were separated from other communities, and the language did not really connect with other languages, so it became very different than other languages. And Italy as a country wants to, because it's in Italy, wants to preserve the language and build machine translation tools, but Google is not providing Ladin. Large language models have no clue. They have some clue because, well, they still have some clue because Ladin is similar to Italian and a little bit similar to Latin. So they can somehow handle, but not really good translation. So this is an example of an under-resourced language like Ladin to do translation. And now the question, do you know what is this tool, this stone? Have you heard about this stone? Have you heard about Rosetta stone? So this particular stone is quite important for history and for the translation, because until the time when this stone was found, researchers could not understand Egyptians' hieroglyphs, right? This kind of strange symbols which look like sometimes animals, sometimes something resembling a human and so on, but we were not able to understand it until during Napoleon Wars. French army was in, I think it was in Egypt, and fighting against some fort. They found in this fort such a stone which have the same text in 3 different languages. One of them was fortunately hieroglyphs from Egypt, which help us to translate hieroglyphs from that time. And this was the same message in the ancient time, I think, I don't know, something like the 1st century of this millenniums. And the same message was to different communities living in that city, right? And that helped us to translate. It is in a British History Museum in London, this tool. Now, common sense reasoning, another task these days, very important because agents are conversing with humans and doing many processes, is this common sense reasoning. For example, we know that going for a walk takes less time than going for a vacation, but for machines, it may not be obvious. It's very logical for us that we can close the door or open the door and keep it open of the closet, but we should not keep the door of fridge open, right? But for a machine, again, it may not be that obvious. And some other sizes of animals, like, you can catch maybe a mouse in a trap, but you cannot catch a giraffe in a trap, at least not to my knowledge, not that easy, and so on and so on. And for this, we have a databases like, for example, atomic database, where you have millions of nodes, and each node represents some action, and then there are some consequences of actions, prerequisite of actions, temporal relations, and so on and so on. As you see here, it's a huge knowledge graph. And if we provide this knowledge graph to large language models, in addition to certain tasks, common sense reasoning tasks, then large language model can consult such a knowledge graph and understand what to do with a task and do it better. It can be domain specific also. It doesn't have to be common sense. It could be any kind of knowledge that is maybe common for certain domain. Well, another pair of tasks, image to text and text to image generation. I'm sure many of you have seen these images and maybe tried systems that can, given a prompt like this one, generate certain images, or given an image, generate a caption of the image, right? So it's bridge between images and text, and more these days we have solutions. With GPT-4 Omni, we have a LLM that can equally understand and process images as text, and videos and audio as well. Now, fake news detection challenge. It's a very important these days, but super difficult. And we have some data sets, we have some organized challenges, but the task is, I think, probably never to be solved. I don't know, maybe you have some suggestions how to solve it, But given a news article that is coming, a very recent news article, how can we tell if it's fake or not? If someone just made it, or if it's a genuine article? Can we have some good computational tools? Can we build a classifier to tell this is fake, this is not fake? How would you do it even if your boss is asking you to, 2 months later, please make a very good classifier to tell if a news is fake or not? What would you do? How would you start? It's super difficult because large language models are trained on human text. They can also generate in a similar way as humans do. We can also ask large language models to make mistakes, to make a bit strange sounding text if you want to make more, text, produce the text that could be made by some not professional, by a user that makes mistakes and so on. It's a very difficult task. Typically, the solutions are look into the context of news article. If it was released on the Twitter, what people talk about it? How often people propagate this news? Are they liking it or not? Are they giving some doubt in the comments? I don't like it, or I never heard about it, or something is suspicious. You can analyze this context, but without this context, it's difficult. Nevertheless, we have some challenges. We have data sets. Community is asked to provide solutions. And this website here, Clay, is a website of a very well-known symposium for solving recent problems in natural language processing and information retrieval. For example, this laboratory like PAN, digital text forensics, you need to assess who was creating a text. Then other tasks like, for example, sexism identification in social networks is very useful, or error risk prediction on the internet, fake news and fact-checking task. So the organizers of these labs, they provide data sets, they provide common evaluation framework, and then they issue the call to teams to submit their solutions. And for students taking part in such tasks, I think it's very easy because you have a data set given, you have a clear evaluation metrics, you have some time frame, and you can quite easily write a paper when you submit a system to this. By the way, we organize Joker Lab. It's automatic wordplay analysis. Is a task to be able to detect humor in text and understand humor, classify it, and generate humor. And the large language models, as we discovered, are really bad at making humor. Maybe GPT-4, I never tested GPT-4, but ChatGPT, we tested, and also some other researchers. If you ask the model to give you some joke, typically it is one of the 25 or so well-known jokes from the internet. It's just memorizing and producing, but it's not making humor itself. Right? Because humor is one of the most challenging things in natural language processing. How to understand humor, and there are different types of humor, and often it relates to context, relates to our emotions, not yet well understood. But humor is still quite important, even in commerce. I remember I talked to people from Alexa, from Amazon chatbot, and they told me sometimes we have very strange requests from customers. Customers say to Alexa, Alexa, please buy me a moon because I want to give it to my girlfriend, right? And then Alexa can say, sorry, but we are not selling a moon, right? Or it's too difficult, or it will take too long time. But Alexa can also make a joke to reply to the user to have a good connection, right? But for that, you need to detect that there was a sarcasm or there was a humor, and then generate a humor. So they are also thinking how to do such a clever assistance. It's not just for pure linguistics study. It could have application in chatbots, in robots, in even in e-commerce, as I said. And then we have, of course, a lot of research on spoken dialogue systems or discourse analysis. We have a research on computational social science, for example, detecting in the Twitter, on Facebook, who is left-wing, who is right-wing, who is supporting Democrats, who is supporting Republicans, not just looking at the links, but looking at the text, understanding the text, and so on. Well, computational journalism these days, news articles, at least some of them are written by machines, at least the first draft, and then later human is, updating it. And this is not something that came with LLMs. Already before large language models, computational journalism was used and was typically used for very structured events. Imagine a soccer game. It's very easy to tell what is important in a soccer game, right? You report a goal, you report a red card, you can report a yellow card if you want. And that's it, right? And you report the result and who scored a goal. It's fairly easy structure to write a journal article from some large, let's say, corpus of data about certain soccer game. But if you want to write some editorial article, opinions and connecting many different facts and contrasting them and so on, LLMs are still not good yet. At least you need a very good human supervision and updating on that. Now, text-driven forecasting, it's another NLP task, especially used by fintech, financial research community. I remember the paper that was, I think, 2008, 2010 about Twitter, that Twitter can predict stock market. And indeed, researchers were showing that there is some correlation, but later other researchers were concluding, okay, Twitter is useful, but only as one of 200 or so signals about a stock exchange. You can't really predict everything from one article and say if the stock will rise or fall in the next hour. But I remember when I was a student in Japan, I met a team in the National Institute of Informatics, NII, that were working, it was in 2007, that were working on a text forecasting tool to predict stock exchange. And they were very successful, and they were using a very, very simple solution. They basically have a system that as soon as news about company comes, the system tells positive or negative, that's all. And then buy a stock or sell a stock, right? And that's all. Why it was working in 2007 in Japan, first of all, there were no such systems. They were one of the first. And second was that in Japan, large fraction of population who have money are older people. And older people read the news, but they don't use, stock trading tools. They go the next day to buy or sell the stock. But that's already too late because, well, tools like these already will put a heavy tax on it, right? The seller or buyer will have now not favorite price to do it if it's too late. Well, some people say that 30% of stock trading is now done by chatbot, not chatbots are bots and all these automatic tools. So research, of course, in NLP is also going, but not just sentiment analysis. That would be too simple. You need to do much more these days to have a good way. And so maybe now we can take a little bit of a Q&A time before I proceed with some materials on basic concepts in natural language processing. Do you have any questions on any of the tasks or some comments that I discussed? Do you have maybe some task you want to work on or something interesting for you that you could maybe ask me or comment, discuss something? Yeah. What kind of assessment?
Text readability assessment.
Really, yeah. Yeah.
So that I was able to see there were scores for each sentence.
Yeah.
So how were the scores determined? Like, were there a combined metrics of the length of the sentence, the words, the color of the words, or were they just classifications?
Right. So text readability has been studied, I would say, from the time of the Second World War or even before. And we have many readability metrics in English, but usually they are super simple. They say, take the average length of sentences, take the average number of syllables in the sentences, and the length of sentence, combine these three factors, multiply by some weights, you get a score of readability. And many such readability measures were proposed, I would say more than 20 easily, and they are still actually used these days. But as you can guess, the fact that text is easy or hard to understand is not just depending on how long are words, how long is a sentence, or how many difficult words you have. It all depends on logical flow of text, on the actual choice of metaphors, on giving examples in a text, on many, many factors. So we thought we cannot apply simple formula of readability metric. So we apply machine learning. We collected German text, because it's for German, from a Deutsche Welle journal, which have easy and difficult text. We collected also some other corpora prepared by other researchers. We trained a BERT model, a transformer, on this classification task, easy and hard. We just divided them into two classes, and we took the score, the class probability as this score, and we just added it to every sentence. Plus, we also colored the sentences. And as I said, if some tool like that does not appear for Hindu or for other Indian languages, it's a perfect opportunity to do one, because it could be quite often used. And if you make a website that any educator, any teacher can copy and paste text and get the overall score, because you see this overall score of the text also, plus for a sentence, it could be useful for educators and also for companies, as I said, that want to make simple instructions to assemble a product, or governments that want to issue, or legal professionals want to issue something understandable. How many times I hear people complaining that legal document is completely not easy to understand? And you can imagine this is important. So yeah, it was based on a transformer, and it's quite easy to build it. It was a bachelor work that was published in a CIR conference, a demo paper. And I was also thinking that many times a visual language is also not easy to understand. I'm not sure if any one of you has purchased IKEA, some furniture, but I was myself assembling furniture, and you have this diagram, and sometimes it's really complex. Then you screw something wrongly, and then you have to come back, unscrew everything, because they didn't care so much if this visual language is really understandable. Really, removing other options and doing like it was an obvious. So anyway, yeah, thanks for the question. Any other question on the task? Anything that you want to ask, if such a task exists, or propose something new? All right, good. So what time is it now? Take a break, right? How long will we take a break? 10 minutes break. Okay. Tea break or coffee. I will take tea, maybe. One more tea, but no milk this time.
No milk.
No milk.
And sugar?
No.
No sugar.
Just water. And the tea.
Thank you.
Sir, can you share the starting slide? Just I missed a few seconds. I joined little late, so just in case you can show.
Starting slide.
Oh, okay. Starting slides.
The first one.
Yeah. I think it is also being recorded. So.
Yeah, it is being recorded now.
Okay, ma'am. No issue. If it's
Yeah.
recorded.
So I was simply giving the introduction of the university, and yeah.
Yeah. But is there any particular question from online?
No, sir.
Okay.
All these outside.
Yeah, so what we do and there are cells. They are mostly Indian students.
Yeah.
Yeah. You are also Indian? Very good. And she is doing project with me. And he is my PhD student. He is Akash.
Uh-huh.
Submitted his survey paper.
He submitted what?
Survey paper.
Survey paper, okay. Which topic on the survey? Oh, yes, of course. And you are writing, preparing it, right?
So that Raghav Jai survey paper, if you recall.
Yes.
Yeah.
Medical document summarization. It already is getting citations on the archive, quite many. Got rejected from ACM computing surveys, right? But you want to go for artificial intelligence, right?
So he modified.
Yeah.
And he has now put the LLM part.
Oh, okay, good. Fantastic. Yeah.
Covered around 48 papers.
48 new papers or in total?
48 new papers.
Okay, we should discuss.
Because this topic is growing exponentially.
Oh, fantastic.
If you see, I have also drawn the graph that paper.
Yeah. So let's meet later and talk.
Yeah.
Is it on Overleaf? Did you share with me already? You did, right? Okay. I have to check.
Bam is shared. I'm not sure.
When are you trying?
I saw that you were there in that overleaf one. I remember.
Perhaps I was, yeah. When are you going to submit?
Sir, we have submitted in the artificial.
It's already submitted?
Yeah. There is a new Spinja journal, artificial intelligence review.
But did we submit it already?
Yeah.
For the new one?
Artificial intelligence review, the Spinja, yes. But they told that it will be a quick review, but they have not yet sent that review.
Oh. Yeah, I remember we worked on that, but I.
Yeah, they mentioned that it will be 42 days. No, within 42 days. They told that within 15 days there will be fast review.
Because I submitted another 2 papers for the same journal and they accepted, and they were quick.
Huh? They accepted?
They accepted. So it's
Maybe the medical thing was.
No, I think.
medical, I think. They
No,
were.
I think we did a mistake. You could have submitted.
No. It relates to how good is the content.
Yeah, it
But
matters.
they accepted.
It matters, sir.
They accepted, and,
If a European is submitting, it really
Yeah.
matters, sir.
and I'm sorry for this
Yeah,
discrimination that
that
happens.
that is my mistake. I could have asked you to submit.
Maybe
Yeah.
better, yeah.
Because he submitted from his account.
Yes, I submitted.
That's-
And a student, yeah.
Yeah,
students
that's why maybe
submitting.
they are not giving importance. So both of your 2 papers got accepted?
Yeah.
In the first round only?
There was 1 round, but it was not too difficult, and we made it. So I hope, if you want, I can write an email to
Yeah,
them. and
yeah.
say, yeah, because how many months project?
It's been almost 2 months. We
2
submitted
months.
in
I think it's a good time.
last week of
to say.
September.
Oh, okay. And it's a good field, and
And already we have
it will
good
change.
citations, no? Already
Yes,
that
on
paper
the
is-
archive it is.
It's already.
It's
have-
15 sites.
15. 15. But no, I think it's even more, 20 something, like 25.
At the last check, it was 15.
But it was started by, was it Raghav Jain? Is he still collaborating?
He has joined some US
I know,
university.
in California.
Yeah.
But why not? He can still.
No, he is out of touch now. We are not able to get any response from him.
Why?
Very difficult getting a response, no?
What happened?
Like that LaTeX file, he has to modify, no?
And there's some
After
questions.
after so many attempts, I requested Raghav
Oh.
that please give the access to the LaTeX file so that he can modify. So it was so difficult.
Which is strange because he's in NLP lab, right? So for him,
but
it's good. to-
I don't know. Now he is not so interested in publication. That is what it.
He's doing PhD, right? No.
He contacted after that they will collaborate, but after that he is gone.
Yeah.
It's like he is not in there.
Yeah, maybe too many projects, too many ideas.
Yeah, I don't know that. He
But he
started.
went to UK, I remember.
Yeah, he went to
Manchester.
Sophia's lab. He
Yeah.
had also very bad impression. It seems he has created with Sophia. Yeah.
My God, I wrote him a good recommendation.
Yeah, exactly.
Oh,
Like
people are not angry with me.
Sophia, one of my PhD student was working with Sophia. So, sir, can you please mute this?
Should have to be.
Yeah, this one, I think. No, there is some. Yeah, second one.
This? No.
Just minimize this.
This one is in here. Speaker. Oh, sorry. WebEx. Okay.
No, this is a meeting.
So, but
Yeah, stop to
share. But it's just sharing, right?
What is this WebEx thing?
वो तो है ना बगल वाला गूगल क्रोम के बगल वाली यही तो है
So how to mute?
स्टॉप स्क्रीन शेयर स्टॉप हो जाएगा
Okay,
mute
yeah.
करने
म्यू कर दीजिए स्क्रीन शेयर।
खाली देखिए मेरा रिकॉर्डिंग चल रहा है आपको ठीक है
हाँ?
इसमें
Kavendra, can you check if we are not muted because we muted before?
No, reset.
Yeah,
I mean,
okay. Thank you. Okay, so let's continue after the break. I will briefly walk over some simple concepts in natural language processing that will be later helpful when we discuss more complex tasks and problems. So first of all, I want to tell about briefly about word segmentation and counting words and the different types of words. So if you see this sentence, the University of Innsbruck is located in the capital of Tyrol. Tyrol is an area, a state in Austria. You would say that there is 11 words. That's very simple. This text is quite simple to count, but imagine if you have a spoken text where someone might be say something like, I do mainly business data processing, right? How many words you would count here in this case, right? That's more difficult because you need to make a decision if this filler, right, or this fragment like main, which is fragment of mainly, should also be treated as a word or should be just discarded if you do text processing, if you do counting of words and so on and so on. And many times we leave them because they might be good for identifying who is a speaker. Some speaker may use a lot of such fillers, a lot of such fragments, other persons perhaps not. It is still a signal that for certain tasks, such as authorship identification, could be useful. And then one more thing, when we talk about words, we count words, is the difference between a lemma and a word form. So lemma is a canonical, a dictionary form of a word, which you have in a dictionary, right? So for a cat, you have a cat. For runner, running, runs, everything has a one dictionary form, run. But you might have many different word forms, which are different variations, inflections of the same word, like plural form here, or running, runner in the example. So you have a lemma, and then you have a word forms. And tokenizing, of course, is important. Now, except for tokens, we have something called types in natural language processing, which means essentially element of vocabulary or a unique word. So if I look again into a simple example, like here, they're laid back on the San Francisco grass and look at the stars and there, it's not finished. But if we wanted to type, and not type, I mean count how many tokens they are, it's quite simple, it's 15 tokens. But if we want to count types, you need to remove redundant words and just tell how many unique words are there, right? So it would be 13 here. We have 13 unique words and some repetitions like the or and are repeated words. So the two basic concepts, as we can see in this example, tokens and types can be easily detected. However, sometimes we may equate the two words as one phrase. Like San Francisco, you would say that it does not make much sense to keep them or consider them separately, like Francisco and San, because they don't have, at least in English, don't have a meaning, or they are not that frequent, at least, to be considered alone. So we can also consider them as one compound word, and then doing so, we would say there are 14 tokens and 12 types in this sentence. Now, types and tokens are useful in themselves if we just combine them and calculate something called type to token ratio of a text, which is just a ratio of vocabulary size, how many unique types, unique words you have, as opposed to, in contrast to the total number of words. And this simple formula can be useful for measuring so-called lexical diversity. How diverse is a text? It could be even one way of telling if text is readable or not, because, for example, a speaker who is not native in a certain language only knows some limited vocabulary, so you can already tell, will this text be likely understood or not by the speaker? So it could be as a one signal of a readability of text, especially for people who are not native speakers, but also it could be the way to even analyze freshman compositions or study the acquisition of language. So here what you can see is a type to token ratio of children in China that were analyzed for this particular ratio. And you can see that based on age, type to token ratio of these children that were speaking Cantonese is increasing. It's not linear increase, but it's definitely an increase because the child has more and more vocabulary, the knowledge of a different vocabulary. So you can quantify the linguistic development of people using type to token ratio. Also, type to token ratio is used these days to detect dementia of patients, right? A progressive decline in memory, cognitive capabilities of humans. You can study it over time, and this could be one early signal of the dementia happening. People work on this as well in medical field. Plus, as I said, in general, lexical diversity, richness, vocabulary richness of text. Now, type to token ratio should not be used just alone, because if you have a text of a different length, you cannot really compare. If I have a 1-page versus 100-page text, I can't compute type to token ratio of them and say one has higher, one has lower, because the effect of the size of text here will interfere too much with this calculation. So what we do sliding window approach, where you divide, let's say, into 1,000 tokens segments, text, compute type to token ratio for each of them, and then you average everything, right? That is the way to do it when the texts are varying much in the size. You want to have a good, fair calculation. Now, another concept in NLP that I want to discuss here, besides what is token, what is type, what is lemma, what is word form, is so-called a zip flow. And Zipf was a researcher in linguistics from the last century, and he proposed a law which is probably one of the most important laws in natural language processing, which essentially tells that if you take words from a corpus, from a collection of documents, and you count their frequency, there will be F, and you also rank them by the frequency, the multiplication of rank and frequency should be constant. That's all the law, very simple, involving 3 constructs, 3 components. That rank of the word, when it's ordered by frequency, multiplied by the frequency is constant. We sometimes operate on the level of probability rather than frequency. It's a simple way to normalize things. Again, it should be constant, right? So let's look if this law really applies. What you see is a very well-known data set of news articles from 1989, so-called AP89, that stands for Associated Press 89. And we look into some words like assistant, toothbrush, hazmat. You see their frequency, you say their rank, and if you multiply rank by the probability, so we converge from frequency to probability, but there is some variation, but not too much. And actually the variation you observe is because one word is super popular, another word is very unpopular. So you have these rather corner cases. If you look into just 50 most popular words and look into this multiplication of a rank and the probability, then you will even more notice regularity, that everything is close to certain value, which here happens to be 0.09 or perhaps 0.1 even. So this law holds over large number of words. And even we can already observe that probability of D and probability of, the two most common words, altogether gives 10% of the frequency of corpus, which is useful because if I remove just these two words, I have 10% less of data to care of, right? And if we talk about gigabytes of text, these two words removal can really decrease the size of data. So now I will plot or show the plot of a zip law. You see the words are here ordered by the frequency from the most frequent one to the least frequent. And what you observe is a very common relationship between words, where you have a very small number of super popular words, a little bit words in the middle spectrum, and a very long tail, a vast long tail of words which are very unpopular, which appear maybe once, twice, or a small number of times in the collection. And what you see here is the same for different languages, whether it's Hindu, whether it's English, whether it's Chinese. It's the same also for combined words, phrases. Only very few phrases are very popular, and a vast majority is just very low popular. So this law applies over different domains, different languages, different document genres, types, and so on. If we plot on a log-log scale, it will look like this. Indeed, there are some variations in a high frequency portion and the low frequency portion, but basically it's a straight line in a log-log plot. For example, here we take our collection of AP89 documents and we plot them on a log-log scale. Now we fit a zip curve. In the middle spectrum, it's nicely approximating. As I said, we have some irregularities at the very frequent and very infrequent spectrum, but still the law applies. What are the implications of a zip flow? And they are quite important. First implication is that if I take words like D and A, basically popular words, often they are called stop words, we'll come back to that later. And if I remove them, I'm reducing size of vocabulary. Of course, I am reducing some information signal, but often I actually can do it and still understand the text. I mean, the machine can still understand the text. So we know that a small number of words, often some grammatical function performing words, can be safely removed to have less data, more manageable size of data. And the good news is that for those words, we have a lot of information. But the bad news is that we have a vast number of unpopular words. And it means that we don't have enough data about these words to represent them as vectors, to understand their meaning. And that is the reality in the text. That's why we need to expand our document collections, have more and more data to have at least a couple of sentences representing particular words. And we may not be able to tell anything about newcoming words, which are in this long tail that is not covered by our collection size. So that's the difficulty. Anyway, another difficulty is that search engine index, like the one maintained by Google company, cannot be static because you always will have a new words added, right? Because if we have, let's say, a couple of terabytes of text, the long tail still goes farther and you will still have many words that are not there because they are so infrequent. So you cannot maintain static size of an index. You need to update it, but you can even be able to tell how much I need to update it. You can simulate the progress of vocabulary increase. Okay, so now about simple operations of the text. One is a case folding. We lowercase everything typically to have, again, smaller size of vocabulary. We treat things same, no matter if they have large capital letter, first capital letter, or a small letter. But sometimes we have to be careful. If you do it on General Motors, you will have just General Motors. You will not have meaning of a company. If you do on a FED, which can stand for agency in US. It may be just becoming a word like fed, feeding animals, or sale, if it's a shortcut abbreviation for something, as I say. So you need to do it carefully, but this procedure is typically done to make it simple. Another procedure is lemmatization. You are converting forms like I am, you are, he is into just one dictionary form B, right? Or these cars variations into one car. So you see that the sentence like here is being lemmatized to this form. Again, this is part of standardization, normalization of a text. We do it. Again, it simplifies the story. And by the way, when someone tells you adults know 30,000 English words, or you need to know at least 5,000 words to be fluent in a given language, this number means after lemmatization, right? So it doesn't mean cars, or MR is, it means a dictionary word, right? So the main portion of the word. In spaCy, we can do lemmatization very quickly, one line of code. This is very well known natural language processing library, quite often used for text preprocessing. Now, stop word removal. I already mentioned that some terms don't have much meaning and can be removed because they are very frequent, like am, is, d, of, and so on. This is so-called stop words. We remove them. For example, we might have a stop word list like here. Someone prepared it, we just use it, and whatever is in a stop word list will be removed from our text collection, simplifying it, making it smaller size. Of course, if you remove stop words and then you still want to process a query from user like this, to be or not to be, you will not be able to return documents. So sometimes we need to retain stop words, but often we do it to, again, decrease the size of data. And some stop words can be also domain specific. If I have web pages, collection of web pages, I may consider the word click to be like a stop word. It's very common in that domain. So you can have domain specific stop words. Now about tokenization, I want to come back to this topic. If I have a sentence, don't you love transformers? We sure do. If I do a simple tokenization by spaces, white spaces, I have don't, you, love, transformers, and you see equation mark is together now because there was no white space, and so on. If I do tokenization by spaces and punctuation, the results will be like this. See, the result is different, and punctuation is separated from the preceding words. And I may use any variant of a tokenizer like the one in spaCy that is rule-based to have certain result. And you see now it's a bit different, like this negation is treated together rather than done as it was the case of a simple tokenizer that is only considering punctuation and spaces. So it's a choice what you need to do, especially when you process text to be put into transformer later. You need to run some tokenizer, and the choice of it will have impact on the data, the embeddings representation of words later on. Now, tokenizers actually these days do more clever division of words into so-called subwords. That's typically what is done for transformers. So that word like, for example, this annoyingly could be decomposed into annoying and ly, or even into smaller components. And this is very useful where you have so-called agglutinative languages that have very long words composed of many inflections, many parts, and you can divide it into subwords. Why the subwords tokenization is useful actually? The biggest reason is that you might have new words coming which you never observed in your training data, but you can still recognize portions of this word, and by this get the meaning of the word by subwords. And as you know from Zipflow, we have a long tail of words, so there will be always new words coming that are very unpopular or that will be just coined by someone. So if we don't have subword tokenization, the tokenizer might say too many times unknown word, unknown word, unknown word, and have no clue how to represent these words. So we then, as a community, as a designers of transformers, we decided not to operate on character level, because character level is not enough meaning if I have vector for each character, but also not on the level of words, because then too many unknown words will be. So the middle solution is going to subwords, represent each subword as a vector, and then this is the input to the transformers. And then we have many data-driven way of finding subwords, like byte pair encoding that is used in BERT, word piece, again used in some transformers, and typically they operate into recognizing common parts of words by statistical counting, essentially. And it's a very simple solution. I could introduce it here, but it would take us too much time. So I only have one slide here for this subword detection that is tokenizer for BERT. If you have a sentence like "I have a new GPU," you see that it found tokens like here, and GP and U was divided into two components, and there is this 2-hash indicator that this is in the middle or at the end of the word, but not at the beginning, and it's a subword. So the choice of tokenizer is actually often neglected in NLP, but actually it's very important. If I come to the story of student who is developing translator for Latin language, you might remember I mentioned it before the break, that the language is spoken by 20,000 speakers, and it's kind of similar to Italian. And when we are building translation for this language, we realized with a student that we should not use tokenizer that was trained on Italian language, because even though they are similar, but Latin is still having many different words that do not exist in, and different subwords that don't exist in Italian. So we have to run tokenization on our corpus first to train it, to recognize what are the common combinations of characters in Latin, not just assume that that's the same as for English or Italian or other language. So I will now go into a second part, text classification. I'm sure you used classification. Maybe some of you are in a computer science. Well, you are all in a computer science, but in different subfields, you may have used classification. But I will talk mainly about text classification, and to give you a common understanding of this task, I will introduce some simple classifiers. Why classification is important? Actually, this is what we humans do all the time. We recognize characters when we look on the text. We recognize words when you look at these characters. We decide what we hear. We constantly do classification. We always assign some meaning, recognize some patterns, and this is classification. It's a, I would say, basic tasks in NLP or basic machine learning problem. In NLP, that you can actually convert many problems, complex problems, to just classification or combination of classifications. So it's important to study it, obviously. And as I said, humans constantly classify things when they detect images, read text, hear text, and so on and so on, right? And classification is typically done in a supervised fashion. As you know, machine learning could be supervised learning, unsupervised, semi-supervised, and reinforcement learning. Although these days people even talk about in-context learning, which is learning that is mainly done by large language models. But typically we use supervised classifiers. That means you have some training data which could be used to train machine to do class divisions. And I heard that Professor Sriparna Saha will introduce you some transformers later on, some deep learning models, and obviously they can be used for classification as well. We will, in this introductory part, talk about simpler solutions like naive Bayes or k-nearest neighbors. as simple classifiers. And of course, for classification, when we classify documents, let's say, into topics like politics or economy or sport, that's one scenario of classification, we need to decide, are we talking about single membership or multiple membership? So a document can belong to only one class, or a document can belong to a couple of classes, just like in case of document C here. So a different variants we might have. And text classification was commonly done. This is one of the big success stories in computing for a spam detection. These days, you are not getting many spam emails, I'm sure. But when I was a student, we had this problem in a much more severe case. And now the mailboxes are pretty good, or mail clients are pretty good at classifying. Gmail is probably the best example. Hardly ever you get some spam reaching you. These days, I'm using another mail client for my university account, and unfortunately, I'm getting still quite many spam because they are not having such a well-trained machine learning. But the task here, as you see, would be to tell, is this email a spam or not? And you can have a couple of features. You can consider, is there personal invocation to someone? Dear Adam, dear Professor Yatov? No, there's not. Okay, that could be one signal. Is there a lot of punctuations like exclamation marks in a text? Is the URL here from university or from outside? And do you have maybe disclosed, undisclosed recipients? You cannot rely on one signal. You need many features to solve this task. But as I said, we have a lot of data sets, because every time user is reading, actually by his or her action, when it's deleting email, is providing a signal to email box providers, email client providers like Gmail, what is spam, what is not spam. So it's very much used. Another well-known example of text classification is the case of Federalist Papers. These were news articles somewhere around 1787, 88 that were circulating in New York, in America. These were written by some authors who wanted people to accept a new constitution of the United States, right? And appeal to the public to recognize the constitution is needed and so on. The problem was that historians don't know who was an author of these news articles. Whether it was James Madison, Alexander Hamilton, or John Jay, it was not clear because they were published as anonymous. We just suspect the three authors, but we didn't know which of the 12 letters was written by whom. And obviously, this is actually a classification task for authorship detection or recognition. And already in 1963, the two researchers used Bayesian methods to tell which of these 12 letters was written by who else. I mean, which of these two authors, which was very easy. What you needed is to collect data for each of them, which we are sure the written text is by either of these three authors. Train the model, 3 models, perhaps, whatever the solution you employ, and then simply take any text and compare to each of the model, if the model is confused or not on this text, and maybe use a classification framework to detect. And then classification of text can be used also for many other purposes. You can take article in medicine and classify to different classes. So that's a kind of domain-specific problem. Let's say to mesh subject category hierarchy. You can do classification for sentiment analysis to decide positive, negative class. You could do it simply looking into the lexicon of sentiment words. You can use other features. Again, it's just a classification problem. So I will very quickly walk over a simple classifier. You need a document, you need a fixed set of classes to decide, and you need, most importantly, decide what's the class of a document or multiple classes. Of course, you can use rules, but as you guess, as you know well, rules are static. It needs to be, first of all, done by experts and then updated by experts, and that is not scaling well. So we use machine learner, which means this trained classifier here that is trained on a set of some M set of labeled documents that has a class provided for each document. And this is nothing else but a function, mathematical function that is mapping from a document to a certain class in this set C of the classes, right? So this is basically a setup for any document classification using machine learning, using classifier. And then we have plenty of them to choose from. Because of the lack of time, I will only cover these two. But you have, of course, logistic regression, you have SVM heavily used, you have random forest, you have decision tree in a simpler way, and neural networks. Often BERT is used these days for text classification. But walking over two very simple ones, KNN, it's so simple, and some people say there is no learning happening because there is simply only comparison or association that is happening. So imagine that I managed to represent each document as a dot here, and I have two classes, red and blue. And there are some dimensions here. Perhaps each document was represented in multiple dimensions, but through dimensionality reduction, I project it into 2 dimensions so I can visualize them easily for you, for humans. And suppose that there is a new coming document X. We don't know what is the class of this document. Is it blue or red? Whatever is the meaning of these two classes. Maybe it's about politics and the sport. But KNN would simply position this document again as a dot and just simply draw some neighborhood. Let's say K1 or K5, where K stands for how many most similar documents we consider, to X. So if I take 1, I'm just looking into 1 most similar document to X. If I'm using 5, I consider 5 most similar document. That essentially means take vector representation of X and compare it by similarity to all vector representations of other documents and find this K most similar one. And simply decide a class, majority class. So if K parameter is 1, I say X is blue class. If K is 5, I see there are 4 red dots in the K5 set, and the class would be red. And you need to decide this K. It cannot be smaller than 1, obviously, but it should not be too large, because then you simply look into majority class in entire collection. And you see there's no learning happening. It's just memory-based, a simple approach. And this classifier actually sometimes performs quite well, but the problem is that it's computationally costly. You need to do so many pairwise comparisons of any new documents coming. You need to do many calculations. Then naive Bayes is actually faster. You don't need to do such many steps at the inference time. And it relies on Bayes rule. The Bayes rule means that a certain conditional probability could be rewritten in another direction of conditionalities, right? So probability of the class given a document can be now represented by these 3 factors, where we have another conditional here, that is probability of a document given a class. And Bayes rule, as you know, is employed in many models, in many domains, not just in computing, obviously. Why this Bayes rule can be useful for us? So we start with a classifier that needs to tell what's the class C to maximize this probability of a class given a document we look at, right? And it's called maximum a posteriori class to be decided. But we use now Bayes rule, which is also shown here, to represent this component, which is quite difficult actually to compute directly by simple combination of coming from the Bayes rule, right? And we can drop the denominator because probability of a document in our collection is uniform. We have just one time each document appears. And these two components can be called a prior portion and likelihood portion. Prior means how often the class is in our training data, and likelihood means the individual features, how they are likely for a given class. And this classifier has the name naive, which means there was some strong assumption done, which we'll show it in the next slide. It's making conditional assumption on the features. Basically, it says that the features are independent from each other, which is obviously a big lie, because we know that if you see a word like, let's say, soccer in a document, the ability of observing the word like game or goal or penalty is also quite high, because you already have seen this word soccer, right? So they are not purely independent, purely random. It's a document on some topic typically. So if you know there is high probability of soccer, you can assume the other probabilities are also high. So it's clear dependence case, but here in this classifier, we make a simple assumption everything is independent just to proceed. So you see that the joint probability of many features, I'm sorry for not X being printed here, but this joint conditional probability can be decomposed into product of individual conditional probabilities for each feature. And what is a feature in naive-based classifier? Typically just a token. Of course, we can have other features. We can have punctuations. We can have font type used, and so on. But typically, we just consider every word, presence of it, as a feature. And by the conditional independence assumption, we just care about individual probabilities of features. We also make a bag of words assumption. That's another assumption that the order of words does not matter, which obviously is wrong because it's an assumption. Well, if we know that John hit Mary or Mary hit John, these are completely different meanings of these two sentences, but bag of words assumption would say it's the same. We don't care about the word order. That's why it's naive. Classifier with these assumptions, and you basically represent the most likely class as a class that maximizes this product, prior multiplied with per feature likelihood given a class. Well, probability of the class, and here is a hard use because we estimate it. It's calculated by how many documents labeled with this class are in our collection, divided by the number of documents. And these likelihood probabilities you can also count very easily by looking at all the documents in the class and seeing how feature is probable in this class. So you estimate this parameter, but you do it only once in a training. And then when a new document comes, it's very easy to take all these probabilities, multiply them together, and decide a class. So it's very fast, actually, classifier. You need to do vector-to-vector comparisons. You just simply tokenize words, get their likelihood for each class, which is very simple lookup operation, and then you multiply everything. There are some problems, though. What if in our training data we didn't see the word fantastic for the positive class? Imagine a situation where you have a review classification into positive, negative, but you didn't observe any word fantastic in a positive. Then your probability would be 0. You simply count how many times fantastic is in positive, it's 0. You normalize, but it's still 0. And that's the problem, because everything else will become a 0. This classifier is based on multiplying probabilities. So what we do in that case, how we solve this problem, we do so-called smoothing. So we always add a fixed value to the nominator, let's say 1. And then we also need to add it in the denominator of the equation here, just to have a still probability distribution. And it's called add-one smoothing. So basically, even if you have a 0 observation of certain word in a class, you will have a non-zero value of a nominator, will give you a small probability, but not 0. And that's the trick we use. Add-one smoothing, provide pre-processed data for calculating these probabilities. And now, how in practice you do these all calculations? Well, the prior calculation is very easy, is the size of a document in a given class divided by total number of documents in your training data. Here, when you calculate likelihood of features, you first combine all the documents in the class to one so-called virtual or mega document, and then within this, how many times you observe certain word, certain token. And then you can apply a smoothing, as I said. Perhaps instead of one, you can introduce some parameter that you can define how you want, a small value typically. You can call it alpha, and then this would not be add one, but it could be then named add alpha smoothing in that case. So it's a more generic version of a smoothing, but smoothing is needed in order to combat the problem of zero probabilities. Then what is another problem is that some words may not be observed in a training data at all. Not even fantastic, that perhaps was only in negative class of the reviews, but not in positive. Imagine another word that perhaps will be observed in an inference time during, we analyzed some target document, but was never seen in a training data. What to do with this word? One way we can say, let's just reject it and don't care about it in the document we just analyzed. Another way, you can try to model probability of unknown words and treat it as another token, another word token, and calculate what's the probability in positive class, what's the probability in negative class, have some meaning of class membership for document containing unknown. These are the choices you can do. Typically, in a simplest solution, we don't care about it. We just ignore everything we never observed in the training data and just discard word from a test data if it is unknown. So before I will show all the calculations that you can actually do on a certain toy example, let me summarize. It's very simple classification method, relies on bag of words, so on the assumption that order does not matter. It makes strong feature independence assumption, which obviously we know it's not correct in reality, but it helps us to do the calculations. It's very fast, it has low training cost, low computational cost, small storage, and works quite well where you have a small training data. If you write a research paper on classification and you use naive Bayes as one of your baselines, no one will complain. It's still fine to use it. Of course, you need more sophisticated classifiers as well to compare with perhaps your solution, but it's still dependable baseline. Now let's look at a simple example here. I will try to shift this here so it's not covering our view. Imagine you have 4 documents in your training data set. Perhaps you removed stop words and you just have these words only to represent meaning of each of them. And you have a class label, Chinese, Japanese. That's a classification task to tell, is this document about China or about Japan? It's a very specific problem, but okay. And now you have a test document D5. You want to decide what's the class, right? And the calculation is very easy. Sorry for the shift here upwards, but probability of a Chinese class is 3 by 4 and probability of Japanese class 1 by 4. These are my priors, which are very simple because to calculate, because we have just 4 documents, we see what's the likelihood, probability of a Japanese class in a training data and what's the one for Chinese class. Now we need all these per feature conditional probabilities, which are also easily calculated if we count how many times Chinese appears, Beijing, Shanghai, Macau, Tokyo, Japan in a Chinese class, and also in Japanese class. So easily you calculate. You see these additions here, that's smoothing. You always add small value 1 to cover the problem of the 0 probabilities. You also need to also add size of vocabulary in the denominator phase. And then you have these likelihood probabilities. In the end, you combine everything and you say that probability of a Chinese class for our test documents is 0.003. And for Japanese class, it's smaller value, 3 times smaller. So you decide the document is of a Chinese class. A very simple calculation, very fast, working very smoothly. And also what is important, understandable by human. Many times for neural network, we don't know why neural network decided certain class. Here, everything is clear. It's easy to even explain to the medical doctor who is using this classifier. So it has a good benefit of explainability. You say, we see Chinese 3 times here, right? That's why it decided, the classifier decided for a Chinese class. Let's see another example. If I have a sentiment data set, I have reviews, 5 reviews with the negative, positive class. I use it to train a classifier and decide a class for the last review. Perhaps this predictable with no fun. Again, I can calculate, I'm sorry for that. Yeah, visualization here, but priors, and calculate these likelihood features per each class. What is maybe different compared to the previous example is that now we observe the word with that was not in our training data. So it's completely unknown word. It's not seen before, then we don't have any probabilities for it. We could, of course, try to estimate, as I said, unknown probability, unknown token probability per each class, but it's just too complex. We can just drop it and proceed with the remaining things, which give us the result that says this is a negative class document. It has higher per negative class probability than per positive. So again, you see, we can use it for sentiment detection. Okay, so I will now, maybe before I stop, because we will now move to another part of slides, is there any question about whatever was shown? Is there anything that was unclear that you want to ask about, clarify? All is fine? Okay, so I'm happy to see that. Let me now change the slides. I hope I can do it smoothly. Right, we can now go to discussions of LLMs. First of all, do you need a break? Should we take a break now? Sorry?
We can take a break.
We can take. I think it's good before we start the new material. So let's take 10 minutes break and come back at roughly 2 o'clock. Okay.
On today only, I mean, since we started bit late from 11, it will be 2 to 3 lakhs today, and then from tomorrow onwards, it will be from 10 to 1, right?
Yeah.
From tomorrow onwards, it will be 10 to 1. Since today inaugural ceremony was there, so it got bit late. Like post 1 o'clock, 1 to 3, you guys can have lunch or whatever. From 3 o'clock, we'll start, or from 1 to 2 is enough, right? I don't like 2 hours gap would be too much. From 2 to 3 tomorrow, Akash is presenting his okay, today Sharmishka will do demo. We have planned, okay, like 4 peers will be presenting their demos. Like if you want to, if you are interested in coding and stuff, practically. So that is also covering very basic. Okay. I've shared the schedule, the email you must have written, right? The title is there of the demo. You guys can follow that. Right from to tomorrow onwards, it's 10 to 1, a break of 1 hour, and then from 2 to 3 times. That's good. It is not for the rest 4 days we will proceed.
Today?
And today, sir will take from 2 to 3 another review. So he wants to complete one more slide. So, like, so then we will need to end whatever you suggest.
Yeah. The second taking.
Today I don't remember how many hours specifically. From 11 we started, right? So 11 to 12 and 1 with 2.5 to 2.5 hours. I suppose. This one will be-
Yeah. कितना तक हुआ दिखने कितना सैंपल रिकॉर्डिंग today we can
Sir?
today we can because now it is almost 2 o'clock.
Don't stop.
Yeah.
And we start tomorrow.
Yeah, tomorrow.
Sorry?
Yeah. Because
That's time from 1 to 2. Okay. So it's the last time we go for lunch. Okay. No
this
problem.
recording, but this recording started with the revolution also, no?
Right, right.
So we will-
Yeah, yeah.
So, okay, so the demo session will start at? So we'll start at 3:30?
Whatever you say.
Yeah. So there will be demo 3:30, okay? It's cover 3:30.
And today's demo is with taking price and discount.
Okay, so online participants, so we are stopping for today. So we will resume tomorrow.
It was 2 of them.